Welcome to the Deep Dive. Today, we're really unpacking something foundational for AI's future. The Model Context Protocol, or MCP?
That's right. You might have heard it called the USB-C for AI.
Exactly. And it's a great hook. We want to understand, what it really is, why it's getting so much attention, but also where the challenges lie.
Because there definitely are challenges. It's not all smooth sailing.
For sure. So the promise is huge, right? An AI assistant just seamlessly managing everything, emails, reports, web browsing, without all the messy custom code.
That's the vision. No more brittle, one-off integrations for every single tool and model combination.
But then you hear about things like the wrapper attacks for developers, maybe security nightmares.
Yeah, the CISO's nightmare, as some sources put it. We'll definitely get into that.
So our mission today, cut through the noise, give you the essentials on MCP based on the sources you've shared. Why the hype? What are the hurdles?
It's fascinating because you see fierce rivals, OpenAI, Google, Microsoft, all actually buying into this standard proposed by Anthropic.
That level of buy-in is pretty unprecedented. We'll explore why later.
Yeah.
But first, let's set the scene. What was life like before MCP? What was the core problem?
Well, one source called it a chaotic mess of custom integrations. And that really sums it up.
Chaotic mess. Sounds about right.
The underlying issue is what engineers call the N times M integration problem.
N times M.
Okay. Use that down. Right. So imagine you have N different AI models you might want to use, maybe GPT-4, Claude, Gemini.
Okay.
And then you have M different tools or data sources you want them to connect to, Salesforce, MailChimp, your internal database, whatever.
Got it.
To connect every model to every tool, you could potentially need to build N times M unique integrations. Custom code for each link.
Wow. Yeah, that sounds like an absolute nightmare to build and maintain. Can you give us a concrete example, like a company back in, say, 2023?
Absolutely. Let's say a company wants an internal AI helper for its sales team. They pick GPT-4. First step, build a custom connector to Salesforce.
Okay, one connector.
Then marketing says, hey, connect it to MailChimp too. Okay, build another custom connector.
Right.
Now someone says, let's try Anthropic's Claude model instead. Well, guess what? You have to rebuild both the Salesforce and the MailChimp connectors, specifically for Claude this time.
So you're just constantly rebuilding bridges.
Exactly. You're drowning in what developers call custom glue. It's brittle, it's expensive, and it just slows everything down.
Custom glue. I like that. It paints a picture. Now, there were some attempts to fix this before MCP, right? Things like function calling or RAG.
Yeah, retrieval augmented generation, or RAG. And function calling, they were definitely steps forward, but they didn't solve the fundamental integration problem.
How so? Why weren't they enough?
Think of it like this. A RAG is like giving the AI a specific book, say a company report, and telling it, use this to answer the question.
Okay, it gives context.
Right. But it doesn't let the AI do anything new, like send an email based on that report. Function calling is maybe like giving the AI a single key. Yeah, an unlabeled key. The AI knows it can use the key to open a door, but it doesn't know which door or how to find other keys or how to ask for the right key.
Ah, okay. So neither gave it a full toolkit or a language to ask for tools.
Exactly. Neither provided a real protocol, a shared universal language for discovering and using a whole bunch of different tools intelligently.
Which brings us directly to MCP. Anthropic steps in, proposes this universal standard.
Aiming to let any AI model connect to any tool, API, or data source.
And they nailed the marketing with that USB-C for AI tagline. It immediately clicks.
It really does. It captures that grand vision perfectly. The big dream is that AI agent seamlessly jumping between tasks, searching the web, hitting internal databases, drafting emails, all without those fragile custom links.
A true plug-and-play future for AI capabilities.
That's the goal.
Okay, so we get the why. Now let's get into the how. How does MCP actually work? What's the architecture? I read it's a three-part system.
That's right. 3 core components: the host, the client, and the MCP server.
Okay, let's take those one by one. The host.
The host is your main application. Think of your IDE, like VS Code if you're coding, or maybe the Claude desktop application. It's the central orchestrator.
The orchestra conductor, as one source put it, makes sense. So what's the client?
For each tool the host wants to connect to, it spins up a dedicated sandboxed client. This is like a little mini program specifically for that tool's interaction.
Sandbox, so it's isolated.
Exactly. For security. So if you're connected to GitHub and Slack, you'd have separate clients for each, spun up by the host.
Got it. Host orchestrates, clients handle specific tools. And the third part, the MCP server.
The MCP server is the actual endpoint for the tool itself, built to speak the MCP language. Each client establishes a dedicated connection to its corresponding MCP server.
So my VS Code, the host, spins up a GitHub client, which talks to the GitHub MCP server, and separately, a Slack client talking to the Slack MCP server.
Precisely. That three-part structure is key for managing connections and, theoretically, security.
Okay, and how do these parts talk to each other? What are the communication pipes?
The protocol itself is designed to be transport agnostic, meaning it could run over different things, but it standardizes a couple.
Right.
For local tools maybe interacting with your file system directly on your machine, it often uses STDIO, standard input-output, simple, direct.
Makes sense for local stuff. What about remote connections, like talking to GitHub's server?
Initially, the main way was HTTP combined with server-sent events, SSE.
SSE. Okay. Why that combo?
SSE allows the server to push updates back to the client proactively. Think real-time notifications or updates, great for interactivity.
Nice. I sense a butt coming.
But as sources pointed out, it created some real scalability headaches. Managing all those persistent, stateful SSE connections can be tough for large deployments.
Right. So are they stuck with that, or is there a fix?
They're not stuck. There's a newer option called streamable HTTP.
Retrievable HTTP. How's that different?
It's designed to be stateless. That makes it much, much easier to load balance across multiple server instances and scale things up.
So a direct response to the SSE limitations shows the protocol is evolving.
Definitely. It's an acknowledgement that the initial approach had issues in the real world.
Okay, so we have the structure, the transport layers, but what are they actually saying over these connections? You mentioned a vocabulary of primitives.
Right. This is the heart of it. The MCP server exposes its capabilities using these defined primitives. The most obvious one is tools.
Tools, like functions the AI can call.
Exactly. Executable functions. The server lists them out, providing a name like issues create for GitHub,
Okay.
a clear, human-readable description of what it does, and importantly, a schema defining the inputs it expects.
Ah, so it's self-describing. The AI doesn't just get a function name. It gets the manual for how to use it.
Precisely. That self-description is crucial for the AI to figure out which tool to use and how.
Makes sense. What other primitives are there?
There are resources. These are essentially read-only, file-like pieces of data.
Like the contents of a code file or a PDF.
Exactly. Or even data from a database record. It's information that AI can access and reason about.
Okay, tools for actions, resources for data, anything else?
Yes. The third server-side primitive is prompts. These are like reusable templates for common, often multi-step tasks.
Prepackaged recipes.
Sort of. Imagine a prompt template called Summarize Document for Legal Review. It bundles the steps needed for that specific workflow. Makes common tasks easier to trigger.
Okay, so the server tells the host AI, here are my tools, my resources, and some handy prompt recipes. But you said the communication goes both ways. The server can ask the host for things.
It can, and this is where things get really interesting and enable more complex sort of agentic behaviors. These are the client-side primitives where the server makes requests back to the host.
Okay, what can it ask for?
The big one is called sampling. This allows the server, right in the middle of executing a tool, to basically pause and ask the LLM inside the host to think, to generate some text or make a decision.
Whoa, hold on. The tool can ask the AI to think for it, mid-task.
Yeah. It enables these really complex recursive loops where the agent can refine its plan on the fly based on intermediate results.
That sounds incredibly powerful, but also maybe a bit risky. Like, couldn't it get stuck in loops or do unexpected things?
Absolutely. The potential for runaway processes is real. That's why the official guidance strongly recommends that any use of sampling requires explicit approval from the human user.
A human-in-the-loop check. That seems essential.
Crucial safety mechanism.
Okay, so sampling lets the tool borrow the AI's brain. What else can the server ask the host?
There's another important one, newer, called elicitation.
Elicitation, like asking for information.
Exactly. It allows the server to formally ask the user via the host for missing information. So if you told an agent, book me a flight to London, but forgot the date.
Instead of just failing or guessing.
Right. The server can use elicitation. The host might pop up a little dialogue asking you, what date would you like to fly? It makes the interaction much more robust and user-friendly.
That makes a lot of sense.
Then,
Handles ambiguity gracefully. Okay, so this whole rich, interactive, open-source design, it clearly struck a chord. The adoption has been massive.
it really has. Which brings us to that unprecedented industry buy-in we mentioned earlier.
Yeah, let's talk about that. It's one thing for Anthropic to promote its own standard, but getting OpenAI, Google, Microsoft on board, that's huge.
It's classic co-opetition, right? These companies compete fiercely everywhere else, but they all agreed to use this common standard for tool connectivity.
Why? What's the strategic thinking there? Why not just push their own proprietary connector systems?
I think the calculation is that a rising tide lifts all boats. That N times M problem, it was hurting everyone.
A bottleneck for the whole industry.
Exactly. By agreeing on the standard plumbing, they solve that shared problem and create a much bigger, more vibrant market for AI agents overall.
So they can then compete on the higher level stuff.
Right. Compete on the quality of their models, the features of their host apps like ChatGPT or Copilot, or the sophistication of their agent frameworks, rather than everyone reinventing the wheel for basic connections.
And this buy-in wasn't just the big AI labs. It spread through the whole tech ecosystem, didn't it?
Oh, absolutely. All layers of the stack. You've got the cloud giants, AWS and Cloudflare, offering MCP hosting and servers for their own services.
Infrastructure buy-in.
Then a whole wave of application partners building official integrations. In productivity, you see Atlassian, Notion, Linear,
Major players.
Finance, Stripe, Square, Communications, Intercom. The list just keeps growing. It built momentum very quickly.
And the developer community seems engaged too, judging by GitHub activity. Like 60,000 stars is a lot.
It's a huge signal, yeah. The main servers repository has over 60,000 stars. Developers are clearly interested in watching it closely.
But you mentioned it's a double-edged sword.
Well, yeah. That same repository also has hundreds of open issues and pull requests.
Huh. So lots of activity, but also lots of problems being reported.
It shows an engaged community, which is great, but it also signals, as one source put it, a maturing protocol with rough edges. Things aren't perfect.
Which perfectly leads us into the hype versus reality part of this, all of this momentum, this incredible adoption.
Yeah.
But what are the actual pain points? What's the developer friction like?
I think the biggest recurring theme is just that implementing and especially debugging an MCP server is, frankly, really, really hard.
Harder than it looks.
Much harder. That stateful nature we talked about, great for interactivity with things like SSE, makes scaling and ensuring resilience a real challenge in production.
And this leads to the term you mentioned earlier, the wrapper tax.
Exactly. Developers coined that term.
Define that for us. What is the wrapper tax?
It's the cost in terms of developer time, the added complexity, maybe even performance hits that you pay just to wrap your existing perfectly functional API inside this new MCP server layer.
So you have a good API, but now you have to build and maintain this extra MCP thing on top of it.
Right. And for simple use cases, it can feel like a really heavy tax. Developers are asking, do I really need all this MCP machinery just to make one straightforward API call? It causes friction.
And beyond just the development effort, there are performance costs too, right?
Yeah.
Something at the context window.
Yes, this is a subtle but significant issue. Context window bloat.
Bloat. Sounds bad. How does that happen?
Well, for the AI model in the host to decide which tool to use, it needs to see the descriptions of all the tools available from all connected servers.
All of them. Even if it only needs one.
Potentially, yes. If you're connected to several complex MCP servers, each with many tools, all those text descriptions get stuffed into the model's prompt.
And the model's context window, its short-term memory, is finite.
Exactly. Those descriptions can eat up a huge portion of that limited space.
Can you give an analogy? How does this impact the AI?
Sure. Imagine you hire someone for a simple one-page task, but before they start, you force them to read a dense 20-page manual detailing every single tool in the entire workshop, most of which they won't need.
They'd be confused. Maybe forget the original task.
Precisely. By the time the AI wades through all the tool descriptions, it might have less capacity left for the actual problem, its reasoning might degrade, and it definitely increases latency and cost because you're processing more text.
Okay, so wrapper tax adds complexity, context bloat hurts performance, and then there's debugging. Sounds like that's a major headache too.
Probably the most common complaint you hear from developers working with MCP.
Why is it so hard to debug?
You build your server, you try to connect it from a host app like Claude Desktop, and it just fails silently.
Nothing worse.
The host applications often provide little to no useful logging, so the developer is left completely in the dark trying to guess what went wrong in that complex three-way interaction between host, client, and server.
That lack of observability sounds incredibly frustrating.
It's a massive point of friction. Adds hours, maybe days to development.
So putting it all together, for a simple task, maybe just calling one API endpoint,
Building a full MCP server can really feel like using a sledgehammer to crack a nut. It's overkill.
heavy-duty solution for potentially simple needs.
And all that friction, the tax, the statefulness issues, the debugging pain, created the perfect opening for a different approach.
Before we get to the alternative, though, we have to cover security in more detail. You mentioned it's a CISO's nightmare. Giving AI keys to the kingdom sounds inherently risky.
It absolutely is. The protocol's biggest strength connecting AI to anything is also its biggest weakness from a security perspective. The attack surface is massive.
How so? Where are the risks?
Researchers look at the whole life cycle. During the creation phase, you've got supply chain risks, like an attacker trying name collision. Yeah, they register a malicious server called, say, GitHub with an L instead of an I, hoping users install it by mistake instead of the real GitHub server.
Sneaky. But the risks during actual operation sound even scarier, like tool poisoning.
Tool poisoning is fascinating and quite worrying. It exploits how the AI relies on tool descriptions.
How does it work?
An attacker creates a tool. It might look normal, but hidden inside the description text of the tool, they embed a malicious prompt injection.
Inside the description, the AI reads to understand the tool.
Exactly. The AI reads the description to decide if it should use the tool, and bam, it processes the hidden command embedded within. It's like social engineering for robots.
Wow. Tricking the AI through a description. That's unsettling. And it ties into another classic security problem, the confused deputy.
Yes, the confused deputy problem is a huge one for MCP. It's a classic vulnerability pattern.
Explain that. Who's the deputy and why are they confused?
The deputy is the MCP server. It might have high privileges, maybe it can write to a production database or delete user accounts.
Okay, a powerful server.
The confusion happens when a low-privilege user tricks the AI agent into asking that powerful server, the deputy, to do something destructive on the user's behalf.
Ah, so the user couldn't delete the records themselves.
Right. But they tell the AI, hey, can you clean up all the old project data? The helpful AI then turns to the high-privilege MCP server and says, please execute deleted records for this project.
And if the server isn't careful?
If the server isn't meticulously designed to check and enforce the original user's permissions for that specific action, it might just go ahead and delete the data using its own elevated privileges. It gets confused about whose authority it's acting under.
Acting with borrowed power it shouldn't have used for that user. And these aren't just theoretical worries, right? Sources mentioned actual incidents.
Exactly. There have been documented security issues with early versions of official servers from companies like Asana and GitHub. It highlights that building these servers securely is hard.
So what's being done? Are the MCP maintainers addressing this?
They are. They're actively working on bolstering the spec, adopting standards like OAuth 2.1 for authentication, requiring resource indicators to scoop token access.
Standard security practices.
Yes, but the core message from the sources is that security is a shared responsibility. It ultimately falls on every single developer building an MCP server to be incredibly disciplined.
Input validation, sandboxing, enforcing least privilege. All the hard stuff.
Absolutely critical.
Okay, so MCP, powerful, widely adopted but complex, tricky to debug, and carries significant security baggage. This sets the stage perfectly for a challenger. The Universal Tool Calling Protocol, or UTCP.
UTCP. Yeah, it's really interesting because it emerged directly from these criticisms of MCP. It represents a fundamentally different philosophy.
Oppositional, even. If MCP is describe and proxy, the server is a middleman. What's UTCP's philosophy?
UTCP's philosophy is describe and connect directly. It completely throws out the middleman server concept.
No UTCP server to build or maintain.
None at all. Instead, a tool provider just publishes a JSON file, they call it a manual, which describes how to call their existing and native API endpoint.
So the AI agent reads this manual and then calls the tool's actual API directly. No MCP server acting as a proxy in between. Wow. That completely eliminates the wrapper tax we talked about.
Gone. Vanished. No extra server layer to build, debug, scale, or secure.
That sounds much simpler.
It is. It's inherently stateless, which means lower latency, easier scaling. And for authentication, it just uses the tool's native method. If the API uses an API key, the agent sends the API key directly. No complex credential mapping.
Okay, simpler, faster, potentially more secure by using native auth. Why wouldn't everyone just use UTCP then? What's the catch? What do you lose?
And that is the core of the philosophical schism here. The trade-off is significant. You lose those rich, stateful, interactive capabilities that MCT provides.
Like elicitation, asking the user for more info.
Exactly. That's hard to do in a simple direct call model. Same for the server pushing updates back to the client in real time. UTCP is really designed for straightforward, simple transactional tool calls. Send a request, get a response.
So it's a trade-off. MCP offers richer interaction but adds complexity and a proxy layer. UTCP is simple and direct, but less interactive.
Precisely. It's a choice between a feature-rich, standardized, but complex intermediary versus a lightweight, direct, but less capable connection.
So bringing it all together then, where does this leave MCP? It has that massive head start, the network effect.
That network effect is MCP's trump card right now. It's huge.
Okay.
Having Anthropic, OpenAI, Google, Microsoft all actively building on it and contributing creates an immense gravitational pull.
Hard to bet against that momentum. Are they addressing the problems we discussed?
They seem to be. The maintainers acknowledge the pain points. The roadmap includes things like compliance test suites to help with that debugging nightmare,
That would be welcome.
and plans for a centralized silver registry, which could help with both security vetting servers and discovery.
So if you're a tech leader, a CIO listening to this, trying to navigate this, what's the strategic play? Jump fully into MCP. Wait and see.
I think the advice boils down to trust but verify. Start cautiously. Maybe begin with low-risk, read-only use cases. Definitely prioritize official servers from vendors you already trust.
Sensible steps.
But the bigger strategic opportunity, the sources suggest, isn't just connecting individual tools. It's using MCP as a catalyst for rethinking your whole enterprise architecture towards something called capability as a service.
Cageous.
Capability as a service. Okay, unpack that. Sounds like a big shift.
It is. Instead of thinking in terms of monolithic applications,
You start breaking down your business processes into smaller, well-defined, discoverable capabilities.
Like modular pieces of business logic.
Exactly. Each capability may be check inventory, create purchase order, verify customer credit, gets exposed via its own secure MCP server.
So you build an internal library of MCP-enabled capabilities.
Precisely. Then AI agents can intelligently find and orchestrate these discrete capabilities to automate much more complex workflows across different systems without needing deep integrations into the monoliths themselves.
Creating a more agile, AI-native enterprise built on these composable capabilities, that's a powerful vision.
It's a way to leverage AI automation without necessarily doing a full rip and replace of legacy systems.
So wrapping up, MCP is clearly the leader, huge momentum, big names behind it. But the race isn't quite over.
Not at all. MCP is racing to mature, fix the developer experience, harden the security before the simplicity, and lower overhead of UTCP, perhaps captures a large chunk of the market that just needs simpler transactional integrations.
The classic tech story playing out right now.
Yeah.
The feature-rich incumbent versus the lean, fast challenger.
And the outcome really will shape how our AIs interact with the digital world for years. It's about the fundamental plumbing of intelligent systems.
And it's fascinating, isn't it, how these seemingly technical choices about protocols and plumbing,
Yeah.
they don't just impact developers, they fundamentally define the capabilities and also the limitations of the AI agents we're all going to be interacting with more and more.
Absolutely.
So maybe a final thought for you listening. As these systems get more capable, how much autonomous thinking do you really want your tools doing? And how much explicit human permission should be baked in before they act? Something to consider.